Okay, first of the circle theory rules. So clip 594, and this is about the angle at centre and circumference. So these are the three shapes. Circle theory is all based on what shape can you see. So one of these shapes relates to one of the theories. So if you can spot the shape, hopefully it'll jog your memory to look at what the theory is. So the two ones that are orange are linked together. The two ones that are blue are linked together. And the two that are in black are linked together. So let's start with this one. So this looks like the Star Trek symbol, like that. So that's the one you're looking for, and it's always this one and this one that are linked. If I move this point round on the circumference, so this line will go, let's say I go to here, this line will go to there. If I went a bit further and went down to here, this line will go to there. But this line would stay the same, so it'd look like this. If I move this one round here, it'd turn into this one. Okay, so these two are the same. Same with this one. If I move this point here around the circumference, it would turn into this shape. Okay, if you use the video on Hecate, at the beginning, it shows you this, and it shows moving this and what happens. So these three are all the same shape for this theory. So the theory is the angle at centre is double the angle at circumference. So you're looking for, if you see these three shapes, the wording you need to write, the reason is the angle at the centre is twice or double the angle at the circumference. So that's the wording you're looking for. And if it asks for give reasons, then that's the reason you'll give. So, number one, example, AOB. That should be AOC. So if we said AOC was 116, so that means AOC, this one is 116. Using that rule, angle at the centre is twice the angle at circumference. This is 116, that's the angle at the centre. That's twice the angle at circumference there. So you want to find out what ABC is. Well, it'll just be 116 divided by 2. So it's 50 and 8, so 58 degrees. Okay, simple as that. Next one, ACB. So ACB, this one's 51. So again, you can see the shape. It's this one and this one that are linked together. It looks like one of these three. The angle at the centre is twice the angle at circumference. So this time, this is 51. So we do 51 degrees times 2. That will get the angle at the centre, which is AOB. So AOB is 102 degrees. Done. Number 3. If AOB is 42, AOB, that one's 42. So that's the angle at the centre, because this O is the centre. If I move this round here, it looks like that one. So this one looks like this one. So it means it's the same rule. Angle at the centre is twice the angle at the circumference. So if that's 42, the angle at the centre is twice the angle at the circumference. That means this one has got to be half of that one. So 42 divided by 2 is 21 degrees, which means ACB equals 21 degrees. Next one, 4. AOB is 156. Now this one's a little bit more difficult to spot. So it's still the centre, but this time it'll be here and not this one. So you need to do 360, take away 156, which is 204. So this one's 204. The angle at the centre is twice the angle at circumference. So 204 divided by 2 is 102 degrees. So that means ACB is 102 degrees. 2 more. Okay, first one, this is number 5. So it looks a little bit trickier, this one, but you just got to try and spot where the angles are linked to each other. So where's the angle at circumference and where's the angle at the centre? So you've got to try and find out what ACB is. So you're trying to find out this one. Okay? So I've got this one, OAB, is 40 degrees. So if that one's 40 degrees, so where's the angle at the centre and where's the angle at circumference? So if I look at this one and I look at this one, these are the two that are linked together. If I move this one round slightly, then it would be like that. Okay, so second thing, that's the centre. That means this and this are both radii or radiuses, which means that this has to be 40 degrees. Okay, so if we know that those two are 40, you should be able to tell me now what this centre one is. It's a triangle, so you do 180 degrees in a triangle, take away two lots of 40, which is 80, and that is 100 degrees. That means this one is 100 degrees. Then that one and that one are linked together by angle at the centre is double the angle at circumference. So this one is half that one. So 100 divided by 2 is 50 degrees. So ACB equals 50 degrees. So the harder questions on circle theory come where you've got to join different circle theories together. And it's about spotting where the circle theories are. If I took that line away, you'd be able to see that straight away. But you put the line in, it makes it more difficult. Think of something else, another rule you might use. Generally, it'll be to do with isosceles triangles. Right, number 6. So AOB is 120. So AOB is 120. So I've got to put in a dotted line there. That's 120. OBC is 35. OBC, that one is 35 degrees. And it wants you to find out what OAC is. So OAC, I've got to find out what this one is. So let's have a look. So we know this one is different colour. This one and this one are linked together because angle at centre and angle at circumference. So these two are linked. Well, this is 35. We know that these are all equal because they're radiuses, which means that you've got two isosceles triangles. That one's also 35 degrees, and this one will also be 120, and this one will also be 35. So what's this one here? Well, if that's 70, then that one would be 360, take away 70, which is 290. So that's 290 degrees. Sorry. That one would be 70 times 2, because the angle at the centre is double, that's 140 degrees. Then you've got another isosceles triangle here. If that's 140, so it now looks like this. These two are the same. 180 take away 140 is 40 degrees. And then divide 40 by 2, because these two angles are the same. Each of these is 20 degrees. OAC, well that's O, that's A, that's C, so it's this one. So OAC equals 20 degrees. Done.